In conversations about energy and electricity grids, most of the focus is on the source of energy generation, whether it's fossil fuels like coal, oil, or natural gas, or renewables like solar, or something in between like nuclear. In the context of climate change, reducing emissions of greenhouse gases like CO2 is very important. But in the context of a power grid, generation is only one part of a much bigger picture. In fact, within a grid, there are three main elements. We can think of each element as the steps electricity takes to get from the generator to our houses. Generation is how power is brought into the electric system. Whatever the technology and energy input type, generation units produce alternating current power at a frequency of 60 Hz, which is then exported into the grid. When current flows through a conductor, it loses energy. Loss amount depends on the resistance of the conductor and the amount of current flowing through the conductor. So, to transmit the electricity over long distances from the generating station to customers, the voltage is increased. Generator output voltage is usually 25 kilovolts or less. Step-up transformers outside the generating stations may increase the voltage to 230 kilovolts, 500 kilovolts, or 765 kilovolts. The voltage may be increased to older voltages as well, depending on the individual power system and the national standards at play. A transmission system is made up of high-voltage power transmission lines that transfer or transmit electricity from remote generating stations to customers. Transmission lines are usually overhead wires supported by towers. Transmission lines can be several hundred miles long. Interconnected transmission lines form a network or grid that connects generating stations to customers. Through the grid, transmission systems also provide a method of interconnecting utilities so that power can be exchanged between utilities when necessary or desirable. Power lines that operate at higher voltages used on a given power system make up the transmission system. Transmission systems also typically have substations. A transmission substation is a facility where transmission lines terminate or connect to other transmission lines. Transmission substations contain equipment to sectionalize the power system and disconnect faulty equipment or equipment requiring maintenance from the rest of the power system. It is usually desirable to reduce the transmission system voltage before the electricity reaches customers. Therefore, most transmission substations contain power transformers to step down the high transmission system voltages to lower sub-transmission voltages. A distribution system is the final step to delivering power to customers. A distribution substation energizes the distribution system that supplies power to customers. Distribution substations contain power transformers that step down the high transmission or sub-transmission line voltage to the primary distribution voltage. Most utilities operate their distribution system between 4 kilovolts and 34.5 kilovolts. Circuit breakers for switching individual distribution circuits are typically installed at these stations. Utilities use circuit breakers to de-energize and re-energize individual distribution circuits that are faulty or require maintenance. The distribution substations supply power to the primary distribution circuits called distribution feeders. The distribution feeders carry power from the distribution substations to reach customers. Overhead wires supported by utility poles are the most common means to support distribution feeders. Underground cables may also be used. Most households receive power at 120 and 240 volts. Business customers may be supplied with single-phase or three-phase power up to 480 volts AC. Some business customers provide their own distribution transformers, which are supplied directly from the primary distribution feeders. As close to the customers as possible, the primary distribution voltage is stepped down by distribution transformers to secondary voltages that can be used by customers. Distributed energy resources, or DERs, are sources or sinks of power located on the distribution system, any subsystem thereof, or behind a customer meter. DERs include electric storage resources like batteries, distributed generation like photovoltaic solar, thermal storage, and electric vehicles and their supply equipment. In most instances, these resources are located close to the end user of power. While individual installations of DER tend to have capacities much smaller than that of central station power plants, The overall quantity of DER installations have grown tremendously, particularly in countries with beneficial policies toward DERs. So, while the sources of energy generation and the many trade-offs the different options might have environmentally, efficiency-wise, and more capture a lot of the public's imagination, transmission and distribution are critical pieces of the grid management equation. Without transmission, electricity generated cannot be effectively moved across the grid. Without distribution, the electricity that is moved across the grid cannot be delivered, and all of the devices that we depend on in our daily lives, in our homes, at work, or in public spaces, cannot draw the electricity required to do their jobs.